Hey guys, how's it going? Mr. Dorado here with another video for you guys on Chapter 4. Today we're going to be talking about Chapter 4.4. So let's go ahead and see how this relates to our unit on inequalities, okay? And this is actually the second part of compound inequalities, which is the AND statements, okay? So let's go ahead and start right away with today's topic. So before we get started, let's just go ahead and recap what a compound inequality is. So all it is an inequality that contains two or more inequalities. So two or more inequalities connected by and actually, why don't I do that in a different color? Connected by and or statements, okay? So they're just connected by the words and, or. So let's go ahead and recap on how we can figure out a regular inequality, then one of the compound inequalities that we did yesterday, which was the OR inequalities, and then today we're going to be talking about the AND inequalities. So let's go ahead and take a look at problem number 1. As you guys know, I always like to start off with an X and the number. Okay, in this case it's a 7. Now we have to identify which way do I have to, or rather what symbol do I have to use here. And because I am going to the right, okay, notice how I'm shading everything to the right of 7, which is everything that's greater than 7. And we have a closed circle, so it has to have the line underneath to show that it's equal to also. Okay, so how do we say this in words? We would say that X is greater than or equal to 7. Okay, so that's all it is. So X is greater than or equal to 7. There wasn't any two different shading regions, kind of like on number 2, so we didn't have to worry about an OR statement. However, now that I mention it, let's go ahead and take a look at problem number 2. So notice we are shading not only to the left of -3, but also to the right of +6. So again, start off with your X and your number. Now, what symbol do I use there? Well, I'm going to the left. I'm shading to the left. And notice the symbol I traced out here. That looks like a less than symbol. So it's less than, and because it's a closed circle here, I have to put the line underneath. Now, if you guys remember from yesterday, I told you guys, if you see a gap like you see here, okay, then that means we have to write in the word OR. Now, you don't have to write it in there, but that helps you remember that here, this is going to be an OR statement. You do have to write the word OR here, not necessarily up here, okay? But on your final statement, when you write your inequalities, you have to write the word OR. So it's X is less than or equal to -3. Now I have another set of numbers here, so X and 6. So the symbol that I traced out here looks like a greater than symbol, which is true because it's everything to the right of 6 is greater than 6. And it is also a closed circle, so I have to use my little line underneath. So how do we say all of that in words? So we would say that X is less than or equal to -3, or X is greater than or equal to, let me scroll down real quick, or equal to 6. Now, don't get these two confused, guys. I know it might be confusing, but this or is not the same as this or, okay? The bigger or that I capitalized, that's just saying that we have two different shading regions. We're shading to the left or to the right, okay? So that is not the same as this one, so don't worry about this or. All this or is telling us here is that the x, all the values are less than or equal to -3, and then we write our or statement, okay? Now, like I said yesterday, basically our compound inequalities that are or statements, we're shading either to the left or to the right, okay? And actually we're shading to both regions, to left and right. But I've always mentioned that there's a small gap here. Whoops, that there's a small gap between the two shading regions. Now, I also mentioned that for compound inequalities that are and inequalities, okay, those would be the exact opposite of ors. So instead of leaving a gap in the middle, they would be the gap in the middle, as you guys can see here. Okay, notice we're not going left or right anymore. Now it's that gap in the middle. But let's go ahead and clarify how to do these inequalities. Okay, so I told you guys it's in there, okay? So why don't we go ahead and do this? Now, because it's that centerpiece right here, all of that that's in the center is my solution set. Everything that is here between the -3 and the 6, so that is where I'm going to put my x. Now, this is what we're going to do. I'm going to write -3, then what's after -3? Well, it's the x. And then I finally see a 6. This is going to be one single statement, okay, guys? So it's going to be one single inequality. At least the way it's written, it's like a single inequality. So you won't be separated by an and statement. We won't specifically say like -3, x -3 and x6, right? We won't do anything like that. We're actually going to make it all look like just one big inequality. Now, we have to find out what symbols to use. And for and statements, they have the property that we always use. We always use less than symbols, okay? It's either going to be less than or less than or equal to. Those are the only symbols that I can use in and statements. And I'll go into further detail, hopefully in the video, to explain why that's true. But because that is the case, we have to decide which ones are we going to use here. Am I going to use the less than or the less than or equal to? Well, let's figure it out. This is a shaded, or rather closed circle, so I have to use the less than or equal to. Okay? Once again, here is also shaded or closed, so I use another less than or equal to. And finally, my answer here is none. So, how do I say this statement? This is how we're going to go ahead and translate it. We say that x is less than or equal to six, and x is greater than or equal to -3. Now, that seems a little confusing, but just think about it, guys. I'm going to do this in, let's see, a bright color. So let's do it in red. So let's look at that first part of my statement, of my verbal translation. It says x is less than or equal to 6. Well, look at my shading region. I'm shading to the left of 6. So to the left means less than, right? So x is less than or equal to 6, which is true. But now notice on my 3, if I'm at my 3, I'm going to shade to the right, and right means greater than. So the whole statement reads x is less than or equal to 6, again because I'm shading to the left. But now x is greater than or equal to -3. So we have those two restrictions, guys. So what is the only area where those two things are true, where you can go to the left and to the right, but basically go towards the center? The only way that works is if I have an and statement, which means I have everything here in between. Okay? Remember how before in or statement we're both pointing to the outsides? Well, these now are both pointing to the insides. So when you verbally translate it, you have to say it x is less than or equal to 6 and x is greater than or equal to -3. Or you could have switched the order. You could have read it as x is greater than or equal to -3, but then x is less than or equal to 6. Okay? Now, I'm going to go into further detail on how we can go ahead and write our inequalities like that. But for now, let's go ahead and see if we can write some new inequalities. So, as we said before, we have to go ahead and find our solution set. In this case, again, I'm shading in the middle here, which means where is my x going to fall? That's how I always remember. Because I'm shading here in the middle, then my x is going to fall in the middle. So when I write this, I write my smaller number first, x in the middle, and the larger number to the right. Now it's just a matter of finding out what symbols I have to use. Well, as I mentioned earlier, we will always be using either less than or equal to or less than symbols. Okay, so let's figure out which we have to do. So because I know they have to be less than, I'm going to go ahead and put them both as less than, but I have to figure out, do I need to put the equal to sign underneath them? Yes or no? Well, this is an open circle, so I don't need the equal to underneath, and this is also an open circle, so yet again I don't need the equal to sign underneath. So my final answer is this, okay? And again, that is red. X is less than 11 and x is greater than 3. Again, x is less than 11 and x is greater than 3. It's trapping everything inside the middle, okay? So that entire middle portion is our solution set. So let's continue. So for number 2, once again, my shaded region is in the middle again, so I know this is going to be an and statement, an and compound inequality, so my x is going to be right in the middle. So I'm going to write my number to the left, which is -6, my x, and then -4. Now let's figure out what symbols we have to use. Again, we only have 2 choices, less than or equal to or less than. So let's figure out which ones do we have to actually use. Well, this is an open circle, so I only use the less than symbol. And this one is a closed, so I use the less than or equal to symbol. This right here is my final answer. Again, to get some practice in, guys, read it to yourself. Do x is less than or equal to -4, and then x is greater than -6. Okay, let's keep going. -5. I have my x in the middle. Remember, we're shading in the middle, so it's an and statement. So because I'm shading in the middle, I have to put my x in the middle, right here. Okay. So let's go ahead and see what symbols we have to use. Well, this is a closed circle, and we always use less than, so it's less than or equal to. This is an open circle, so it's just less than. Okay. Number 4, same thing, -3, x, and 10. They're both closed, so I know I'm going to have to use an equal to underneath, and we always use less than. Number 5. Well, actually number 5 is not an and statement because it's only shading one way. It's only shading to the right. Because it's only shading to the right, then this is just a regular inequality. So we can write it x and 20. And I don't know why that's deleting, but whatever. So x and 20, and we have to shade to the right, which is greater than 20. And because it's a closed circle, we have to put x is greater than or equal to 20. Finally, problem number 6, we're shading both to the left and to the right. So to the left, or, and again, there's a gap there, so that's an or to the right. So we're going to have an or statement. So I'm going to write x and -3 right away. So which way am I shading? I'm shading to the left of -3, which is less than, and because it's an open circle, I don't need an equal to sign underneath. So actually, let me rewrite that part. There we go, that's much better. Now, again, it's an or statement, so make sure you write or x and -1, and once again, which way am I shading? I'm shading to the right, which is greater than, and it's an open circle, so no need for an equal. Okay, now let's go ahead and look at number 7. Number 7 means, or not number 7 means, number 7 says that we have some inequality, okay, and actually that looks like an and statement, right? Looks like an and inequality, but we don't have our solution set yet because we actually have to solve for it. So let's actually try solving this first inequality. So the first thing we should do is divide by 8, okay, because I want the x by itself. We know we always have to have the x by itself, but let's be careful. If I divide by 8, I have to divide by 8 on usually on both sides, but notice we have numbers on the left and on the right side. So I'm going to have to divide it on all 3 sides. Okay, let's see what we get. Well, on this left side, I get a -3 less than or equal to x less than or equal to negative. And just like before, guys, I have my smallest number on the left, my x in the middle, and my larger number to the right. So we're going to go ahead and graph it just like that. -3 here, a -2 there, and where's my x? My x always falls in the middle, so I know it's going to be one of these and statements, so I'm going to shade right in the middle. Now it's just a matter of, do I have to use an open circle or a closed circle? Well, this is less than or equal to, and this is less than or equal to as well. So 2 closed circles, okay? So that is my graph, okay? Again, it's an and statement. How do I know it's an and statement? Look at where the x is. The x is trapped in the middle. Hence why I wrote it up here in the middle between -3 and -2. So because it's an and statement, then I have to shade in the middle. Okay, let's try number 8, and then I'm going to have you try out number 9 on your own. So number 8 says -9 is less than a minus 4 is less than 3. So I want the a by itself. Always try to get that variable by itself. I'm going to add 4 to get rid of that -4, but remember to do it to every single side. So what do I get? I get -5 is less than a is less than 7. Well, that's it. That's my inequality. And again, my excuse me, sorry about that, guys. And again, my variable a is in the middle, so this is also an and inequality. So I'm going to put my smaller number on the left, larger number on the right. I know my x goes here, and so I'm going to shade in the middle. Now it's just a matter of whether I have open or closed circles. Well, they are both just less than, none of them are equal to, so I just go ahead and draw 2 open circles. And again, guys, you don't have to write this x here. You can erase it and erase this one as well. I just like writing it there because it kind of helps me model this right here. It helps me model that the a is in the middle, so I know I have to put my a in the middle, okay, between the -5 and the 7, okay? Whoops. All right, so let's go ahead and continue. So what I want you guys to do is continue solving these. Now I want you to do 9 and 10 on your own. Don't do part A and B, so the questions underneath. I just want you to go ahead and solve for the inequality and graph it on your number line. So go ahead and do that right now and find your solution set. All right, let's see if we can figure out these answers. So I want this x all by itself, so let's subtract 1, subtract 1. I get -4 is less than 2x is less than or equal to 4. Last step here is to get rid of that 2. So I'm going to divide everything by 2. I get -2 is less than x is less than 2. That's great. And again, I see right away that my x is in the middle. So what kind of statement do I have here? What kind of inequality? I have an and compound inequality. So let's go ahead and do my 2 points, -2 and 2. And I know my x has to be in the middle, so I'm going to shade in the middle. All right, now it's a matter of finding out what symbols I have to use, okay? Well, this one was just a less than by the -2, so it's just an open circle, but this one by the +2 is a less than or equal to, so that one is shaded. All right, so hopefully you guys got that for your answer on number 9. Now let's try out number 10. Number 10, we have x divided by 10. So what is the opposite of dividing by 10? Multiplying by 10. So multiply each side by +10. So we get -10 is less than x is less than or equal to 0 times 10 is just 0. Again, this is my inequality now. So let's go ahead and write my 2 values. -10 and 0. Because my x was in the middle, I know this is, again, an and compound inequality. So I'm going to shade in the middle. All right, give me 1 second, guys. Okay, so what symbols do I have to use here, or rather, which type of circles, open or close? Well, right here it's -10 is less than x, so less than is just an open, and less than or equal to for the 0, so this one is a closed. All right, let's try to answer these questions here for each of these problems, for part A and part B on problem number 9 first. It says, is x equal -1 a solution to the above inequality? Well, let's see, where would -1 fall in all of this? Well, between -2 and 2, right down the center would be 0, okay? And -1 would actually be right here. So is -1 part of the shaded region? Yes, it is. So we would say yes. X equals -1 is a solution because it is in the solution set or the shaded region. So it is part of the solution set because it's right here where I have my red shading, okay? Now it says name a possible solution to the above inequality. Well, I just showed you guys another point that's in here. The 0. 0 is a solution, so we can say something like x equals 0. Okay? Now that's not the only solution. There's actually infinite number of solutions here, but maybe what about number 1? So x equals 1 is also a solution. So there's multiple answers here, guys. You could choose whichever you want. You could even choose a fraction. Say x equals 3/2, which is about 1.5, which would fall somewhere right here. 1.5, and that totally doesn't look good. So why don't I do this? 3/2. Okay? All right, let's go ahead and do number 10. So it says, is x equals 3 a solution to the above inequality? Well, it looks like 0 is the point furthest to the right. So 1, 2, 3 would be on the side that is not shaded. So we would say x equals 3 is not a solution because it is not in the shaded region. So it's not a solution because it is not in the shaded region. Remember, guys, whenever you're trying to identify whether or not these things are in the shaded region, or rather in our solution set, just always remember that to the right, so values to the right are greater. Okay, so if I have a 0 here, then values that are greater than 0 are all to the right, and values that are less than are always to the left. So values less than negative 10 would be like negative 11, negative 12, negative 1,000, okay? All right. Now it says name a possible solution to the above inequality. Well, let's think of a number that's in that blue region right here. What number would be in between 0 and negative 10? Well, one that I can think of right off the bat is negative 5, because that would be right directly between those two numbers. So that's the answer I'm going to go with. X equals negative 5. Okay. We are going to go ahead and try number 11 together, and then I want you guys to do number 12 on your own. So let's go ahead and get started on number 11. First things first, get the x by itself. I'm going to add 1 to all three sides. So I get 56 is less than or equal to negative 7x is less than or equal to 63. Now, I have to divide by a negative 7. But what do you guys remember about dividing by negative numbers? And actually, I put it right here. Okay, remember when dividing or multiplying by negative number, you must flip the inequality symbol. Okay, so 56 divided by negative 7, that's a negative 8. Now I have to flip that inequality symbol, so now it becomes a greater than or equal to. This now becomes an x, and once again, I have a greater than or equal to, what's 63 divided by negative 7? That is a negative 9. Now, I can't use this yet because what did we say earlier about these and inequalities? I know it's an and inequality first off because I see that the x is in the center, right? We said that first off, we can only use less than symbols, and these both are greater than symbols. Now, we also know that in order to write our both of our numbers, we have to put the number that's smaller on the left side and the number that is larger on the right side. Well, as it sits right now, whoops, didn't mean to write all over it. As it sits right now, this is the smaller number, and this is the smaller number, or this is the larger number right here. So what we have to do is actually rewrite this so that I have the negative 9 here and the negative 8 there. So again, my x is still going to stay in the middle, but remember, if I rewrite it, always pay attention to, remember my Pac-Man, guys? To keep this consistent, right now my Pac-Man is eating the negative 8, so when I rewrite it, I have to write it so it's eating the negative 8. Okay? Same thing here. On this right-hand side, my Pac-Man is eating the x, so when I rewrite it, it has to eat the x. And now look at that. Now it fulfills everything we needed. The smaller number is on the left, the larger number is on the right, so I can write negative 9 and negative 8. The x is in the middle, just like we wanted, because we know it's an and statement, and look at both symbols now. They're both less than symbols now. So we know we can now graph. So because it's an and inequality, shading in the middle, what kind of circles do I use? Well, they're both less than or equal to, and because they're both equal to, then that means I have to use closed circles. So I have my graph. Now let's see if we can answer part A. It says, is x equal -7 a solution to the above inequality? Well, let's think about it. Where would -7 fall first off? Well, again, I said the larger values, so the more positive values are to the left, and the more negative values are to, the more positive values are to the right, the more negative values are to the left. So, is -7 more positive or more negative than either of these numbers? Well, yeah, -7 is more positive than -8, so it actually falls over here. Is that within the shaded region? No, it's not. So, x equals -7 is not a solution. Not a solution to the above inequality because it does not fall in the shaded region. Okay? All right, so again, let's recap real quick, guys, so you guys can try out number 12. What did I do? I started out with -7x minus 1 in the center. I want to get just the x by itself on the center, so I added 1 to both sides. Then I had to divide by -7 here to get rid of that -7. Because I divided by a negative number, my symbols had to flip. Okay, my symbols had to flip. Okay, so from here to here, notice they went from less than or equal to greater than or equal to. Same thing here. They went from less than or equal to greater than or equal to. And then because I notice here that my -8 is actually larger than -9, I had to rewrite. So what did I do at this step? I rewrote my inequality. And because I rewrote, I was looking to make sure that my inequality symbols were still pointing the right way. And now I was able to go ahead and graph. All right, so what I want you guys to try out is number 12. I'll help you guys out getting started. Subtract 2 to every single side, and then just be careful and remember this tip. Okay, so go ahead and try out number 12. All right, so let's see how you guys did on number 12. So here, after subtracting the 2 on all sides, I get -1 is less than -x over 3 is less than 2. Well, let's see. How do I get rid of this 3? I have to multiply by 3. So that's a positive number, so we don't have to do anything yet. No flipping. Whoops. So what do I get? I get a -3 is less than -x less than 6. But look, I have a -x. I don't want a -x. I want a negative, or I'm sorry, I just want an x. So I can think of that as a -1. So let's divide by -1 on all 3 sides. Now I'm going to be flipping here. Okay? -3 divided by -1 is a +3. And because I multiplied by a negative number, or divided rather by a negative number, I'm going to flip. So now I get greater than symbol, x, and another greater than symbol, and -6. And just like in the previous problem, guys, notice right here, I have my larger value on the left and my smaller value on the right. I can't have that. I need to make sure I rewrite this so that my smaller value is on the left and my larger value is on the right. So what am I going to do? I'm going to go ahead and rewrite this. Let me pick a different color here. So I'm going to write the -6 here, the x, and then the 3. Okay? So if you guys remember, I always use a little Pac-Man reference here. That little Pac-Man with his mouth open, it's trying to eat the 3. So I have to make sure I keep that consistent because I'm not flipping again. I'm rewriting at this point. So this right here is rewriting. So I'm just changing the order. I'm not flipping the sign. Okay? So again, where's my little Pac-Man eating? Is it eating the X or is it eating the 3? It's about to eat the 3. So I have to make sure I rewrite my symbol so it's eating the 3. And I don't know why I rewrote that part. So it's eating the 3. Now same thing here. Between the X and the -6, my Pac-Man is eating the X. So I have to make sure it's eating the X. And notice now, whoops. Notice now, my smaller numbers on the left, my X is in the middle, and I have less than symbols. So now I'm good to go. I can graph now. So let's go ahead and put my -6 here, +3 there. What symbols do I use? Well, I use less than symbols, so no need to shade. They're just open circles. And now I have to just shade the middle. Okay, I shaded the middle. Now I go check possibly if number 4 is a solution here. Whoa, 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 what's going on? So, is number 4 a solution? Well, what do you guys think? Between 3 and -6, okay, is -4 a solution? Well, let's think about it. If you're still not sure, confused, and maybe you're not sure at all whether or not that -4 is a solution, I would recommend you this. Start at 3, guys. And notice how here, as I keep going to the left, I'm getting smaller. Okay? Start counting down from 3. Okay? And then if by the time we get to -6, you have not said the number -4, then it's not a solution. Okay? So let's think. If you think of 3, so you go down 1, you'd be at 2. Down 1 more, you'd be at 1. Down 1 more, you'd be at 0. -1, -2, -3, -4, -5. Wait. Backtrack. -3, -4. We did say -4. So we said -4 before we got to -6. So that means that x equals -4 is a solution. And why? Because it's in the shaded region. Okay, guys. Good. All right, I think for now I'm going to go ahead and end the video there. Now, if you guys want to know more as to why this happens, so let me go straight up to the top. I'm going to make a video dedicated specifically for that because I think there's a lot of conceptual knowledge going on here that we need to make sure we understand as to why we write and inequalities in this form, okay? Because right now, I gave you this. I told you this, that you have to use less than symbols only, okay? Now, why is that true? Why do you only have to use less than symbols? So what I'm going to do is I'm going to make a separate video to explain to you guys why that's true. I don't want you guys to just kind of take it for granted and always follow that procedure because it's not all procedural, guys. You guys have to conceptually understand why some of these things work. If you do, trust me, everything else becomes so much easier if you just understand the basics, okay? All right, so what I'm going to do is stop the video here. So go ahead and try out your homework for 4.4 and see how you do. Come back to this video and watch any portion of it if you need some extra help. All right, guys, well, I'm signing off for now, so I will see you guys later. Bye.